Good evening. It's been a week since I, interact with you guys, and I think the session on inequalities went on fantastically. So today we have a session on data sufficiency strategies, right? If you ask me, data sufficiency is the some people feel it's the trickier bit of the entire quant section. For me, it's the more easier bit of quant the entire quant section because data sufficiency, right, is more to do with reasoning, and it doesn't require you to actually get to an answer. Okay, so just a quick audio check, guys, before we start. Can you please quickly type in the chat window if I'm audible? And I'll also be sharing my screen with you. So once that's done, we can start right away. Perfect. So let's start off with today's session, right? Um, so this is what I have planned, and this is the agenda of the session. We're going to deal with data sufficiency strategies. I'm going to speak about how you would prioritize plugging in versus analysis. Right? Where would you plug in values? How would you plug in values more importantly? And where and which types of questions would analysis be more preferred? We'll also look at a very good data sufficiency strategy on combining two statements whenever you come to the point of combination. We'll also look at a strategy to approach algebra-based questions on word problems, inequalities, and so on. And we'll also look at one strategy to end with when it comes to geometry. Okay, so what I'm going to speak about here, right, forms like the foundations of everything to do with data sufficiency, right? I'm going to speak about all blanket strategies that you'll require for all topics. Okay, there are certain topic specific strategies as well, but I'm not going to get into that because it requires your understanding of certain concepts. So today it's going to be an overview of the really important strategies on data sufficiency. Okay, so I'm going to toggle between a PPT and a writing screen. So I have a writing screen here. I'm assuming all of you all are able to see my screen. So I'm going to toggle between these, right? So I'm going to start off with one question. Okay, and what I'm going to do with this entire question is I'm going to explain two strategies with one question itself. Okay, the rule is once I give you the question, I want all of you all to take approximately 2 minutes to solve. Once you're done solving, I want you to type your answers in the chat window, and based on your answers, right, we'll have like a very good brainstorming discussion on these questions. Okay, so my first question to you is Z even? First statement, 3Z is even. And the second statement, 5Z is even. Just a little caveat here. I'm not going into what the format of a data sufficiency is. I'm assuming all of you all know what the format is. You're going to be given a question. You're going to be given two statements, and you have to work with the statements individually first before combining, and you have to pick one out of A, B, C, D, and E as your answer. So I'm given a question here. I want all of you all to give a shot at this question, and we'll have a good in-depth brainstorming discussion on this. Try it out, please. And please type in your answer in the chat window. If you're not getting an answer right, give me the best possible answer, please. For those who have logged in, guys, I've just given a question. I'm going to use this question as a foundation of explaining what are the different strategies that you can use for data sufficiency, right? So give it a shot and give me an answer, please type in the answer in the chat window. Okay, so that's 2 minutes. Okay, so I see that most of y'all have given me a D. Some of y'all have given me an E. One of y'all, two of people now have given me a C, right? So let's look at this, okay? Before going into what the answer is exactly, let's brainstorm on this question slightly, okay? See, there are always two approaches to solve any data sufficiency question. The first is an approach that most of the students prefer, and that is the approach of analysis. And the second is a slightly, a layman approach of sorts of plugging in values. Whenever you see any data sufficiency question, right, the key to how to solve a data sufficiency question lies in the question stem. If you're able to read into the question stem, take pieces of information out of it, the statements are going to become very easy for you to solve. I know the question stem here just asks you is z is even, right? But it gives me more pieces of information, because what I notice here in this question is there are no constraints that apply to this question. You see, the question is just z even, but they have not told me what kind of values z can take. Z can take either fractions, positive integers, negative integers, roots, anything I want, right? Because they haven't put any constraints for Z. And most of y'all, right, since y'all get D as an answer, y'all have overlooked the fact that the value of Z can also be a fraction, right? And that is why, right, this simple question, on the face of it, this question looks very, very simple, but it becomes more complicated when you think about the different types of numbers that you can use. So the point I'm making is this. There are two approaches to solve any data sufficiency question: analyze and plug in. You determine the approach depending on the question stem. If the question stem gives you certain constraints, what do I mean by constraints? It tells you that x and y are integers, or x and y are positive integers, z is an integer, z is even, right? If it mentions some important data about the variables that the question deals with, then always go the route of analysis, because the route of analysis, right, or the concept of evens, odds, primes, composites, integers depends upon the fact that you're working with integers itself. But if constraints are not given, right, the safer approach, especially while working with the two statements individually, is to always plug in values, right? Always plug in values. So for most of the people who gave me D as an answer, this would be a big trap answer, because then you overlook the fact that Z can also take a value of a fraction. So looking at this question, I know there's no constraints given to me, so I'm going to go the route of plugging in. I'm not going to analyze. Now, this is how I would plug in. If you're plugging in values, right, on a data sufficiency, you have to be very structured in the way you plug in values. You have to make sure that the initial values that you plug in have to satisfy the information that the question stem gives you, or the statement gives you. So the first statement tells me that 3z is even. So what I'm going to do is I'm going to quickly plug in a value for z that satisfies this statement. So I'm going to put z is equal to 2. And what value you use in the beginning, I'm going to leave it up to you. Okay, as long as you put in a value that satisfies the statement. So if I get 3 into 2 is 6, 6 is definitely even. But since this is a yes or no data sufficiency, right, I need to take this value of z and I need to answer the question. So z is equal to 2 gives me a yes to the main question, because z can be even. But the key to plugging in values, right, is you should not plug in values to prove sufficiency. You should always plug in to prove insufficiency, right? If you've got an answer of yes, try to negate that answer and try to see if it's possible for me to get a no. If you've got a no initially, try to negate it and try to get a yes. You see, is z even? There are two ways I can answer this question. I can answer this question with a yes if z is even, But I can also answer this question with a no if z is not even, right? If z is odd or z is an integer. So when I see the statement 3z is even, I've already put a value z is equal to 2, which satisfies the statement and gives me a yes to the main question. So I'm going to use a value which is going to satisfy the statement but answer the question with a no. And what kinds of values will answer the question with a no? If I take values of z which are odd or fractions. But I can't use z is equal to odd because 3 into an odd number can't give me an even value. But I can always use fractions here. So I'm going to use z is equal to 2 by 3, right? Or 4 by 3. So if I use z is equal to 2 by 3, 3 into 2 by 3 gives me an even number, but z here is not going to be even. So the first statement is clearly insufficient, and the three possible answer choices are B, C, and E. Okay with this, guys? So there's two big takeaways here. What are the two big takeaways? The first takeaway is whenever you're working with a data sufficiency question, look at the question stem and figure out whether you have to analyze and plug in. How? If constraints are given, always choose analysis. If constraints are not given, always plug in. When you're plugging in, right, always make sure you choose a value to satisfy the statement. But after you choose a value to satisfy the statement, you make sure you answer the question. Try to set up an initial yes or no. But in the next example that you take, always try to counter the initial answer that you got. So if you got a yes, try to get a no. If you got a no, try to get a yes. Make sense, all of y'all? Okay with the first statement and how I broke it down? If you're okay with that, I can continue further. Right? So I've already given you two very, very important points. It's a good question. There's a lot of traps here associated with it. Okay with this, guys? Can we continue to the second statement? Perfect. Okay, so here's the second statement. The second statement says 5z is even. So quickly I can put in value z is equal to 2 will satisfy the statement but give me a yes to the main question. But z is equal to 2 by 5 is going to give me a no to the main question. So I can knock off B. So it's very quick for me to knock off alpha and beta, right? Now I need to combine the two statements. Now this is the most important strategy of data sufficiency. When you combine statements, right, never try to analyze, never try to plug in values. Worst ways of working. When you combine statements, the best approach to utilize is an algebraic approach. You can always substitute one statement into the other, right? Because both statements given to you are definite truths. Or you can use a mathematical operation or mathematical operations, multiple mathematical operations between the two statements, which lead to answering the main question. Very, very important strategy of data sufficiency. Always make sure you substitute one statement into the other or use a mathematical operation or a combination of mathematical operations that leads to answering what the question asks you. So what I've been given here is I've been given two pieces of information. I've been given 3z is equal to even and I've been given 5z is equal to even. Now what I need to do is I need to think of a mathematical operator or two mathematical operators or three, how many ever you want, which answers information about z directly. So what I'm going to do is I'm going to multiply the first statement by 2. You see what I'm doing is I'm using an algebraic approach. By multiplying the first statement by 2, right, what I'm getting is I'm getting 6z is even. Because 2 into 3z is 6z and an even into 2 will also give me an even value. And from the second statement, I have 5z is equal to even. And by subtracting the 2, I get z is an even value. And it answers exactly the question that I want. So you see what I did? When I combine the statements, I did not go the route of plugging in because plugging in will be very difficult for me since I have to pick a value now that satisfies both statements simultaneously. What I did is I tried to use a mathematical operation between the two statements, or I could have also substituted one into the other. Now, the key is what mathematical operation you choose, right? The best mathematical operation you choose should be a mathematical operation or a combination of mathematical operations that answers what the question asks of you directly. Now, obviously, your questions in your head would be, why couldn't I subtract the two? Because subtracting the two, right, is going to give you a third piece of information called 2z is equal to even. But what happens now is you're making a third equation, which anyway you'll have to cross verify. Then go back and verify whether 5z is even and 3z is even, and then answer the question. You could have also added the two statements and said 8z is even, but 8z is even is not giving me information about z directly. I have to do a third level of analysis there as well. So the best mathematical operation you choose, right, should be an operation that leads to answering the main question. Make sense? So a quick summary of the first points. These are very important points, and that's a fantastic question to work with because it puts in certain ground rules for data sufficiency. First, always choose between analysis and plugging in versus plugging in. How do you make that choice? You analyze whenever constraints are given. You always go the route of plugging in when constraints are not given. Why? Because when constraints are not given, you'll have to think of numbers which are fractions, roots as well. Second, if you're plugging in, right, always plug in to try and prove the statement to be insufficient. Never try to prove sufficiency, always try to prove insufficiency. If in the process of trying to prove insufficiency, you're not able to, right, that's when you say that the statement is sufficient. And finally, when you combine statements, right, always try to use or substitute, right, substitute one statement into the other, or use a mathematical operation or a combination of mathematical operations between the two statements which lead to answering the question. That is key, right? Your end goal should always be to answer the question. Make sense? So I'm putting in three very, very important ground rules on data sufficiency, and we'll look at different examples building on this. Okay with this, guys? So any quick questions that you have, you can ask of me quickly. I'm going to give you a minute. Any questions in the example that I used? Because if you get a hang of that, I'm going to make the questions a little more complicated. Okay with that, all of you all? Guys, okay with this? Okay, can we continue to the next question? Perfect. Okay. Now, so here's the next question. Okay, I want to see how you would approach it. It's an official question. Um, let's work with it. Is y positive? First statement. 2x minus 2y is equal to 1. And the second statement, x by y is greater than 1. So same rules apply. I want all of you all to take a couple of minutes, solve, and give me an answer, please. And keep in mind what we discussed just in the previous question. Okay, your time starts now. I see only one answer so far. Guys, quickly, if you're not getting it, type in the best possible answer choice, okay? Okay. Okay, so most of you all are giving me a C, some have still given me an E. Okay, more E's coming in. Okay, so let's analyze this question again. Okay, so like I said, there are two approaches to any data sufficiency question: analysis or plugging in, and you determine which one you're going to use depending on the question stem. Since there are no constraints given to me about X and Y, right? The best thing to do is to opt for the route of quickly putting in values when you're working with the statements individually. So I'm going to work with the first statement. The first statement says 2x minus 2y is equal to 1. So I can simplify this to x minus y is equal to half, right? Now what I'm going to do is I'm going to quickly put in a couple of values to try to get a yes and a no to the main question. What's going to give me a yes? A value of y which is positive, and what's going to give me a no? A value of y which is negative, right? Or 0. Now when you plug in values, right, keep in mind that 0 and 1 are quick reference values that you can always use, 0, 1 and minus 1 as well sometimes, right? So don't use values like 4, 3, 10 and so on, right? 0 and 1 would always serve the purpose very quickly. So what I'm going to do is I'm going to put x is equal to 0 first. So if x is equal to 0, for me to satisfy the statement, y has to be equal to minus half, right? Now I'm going to take this and I'm going to answer the main question. Is y positive? I get a no to the main question. Now I have to plug in two other values, which tries to give me a yes to the main question, right? So I'm going to put x is equal to 1, and obviously y has to be half here, right? So 1 minus half is still half. It's satisfying the statement, but it's giving me a yes to the main question. So I can knock off the first statement. Now, what does the second statement say? The second statement is more easier to analyze. It tells me that x by y is greater than 1. Now, the big mistake, especially for people who marked E as an answer, right, is for people to say X is greater than Y, right, to multiply both sides by Y. But this is completely wrong, guys. Okay, remember what we discussed in our inequalities webinar last time? I said that you can never multiply or divide with a variable until you know the sign of that variable, right? Here I don't know the sign of y, so it doesn't make sense for me to pull the y to the right hand side. But just analyzing this equation, right, you'll realize that for me to have this equation to hold true, both x and y can be negative, or both x and y can be positive. For example, x can be 3, y can be 2, or x can be minus 3 and y can be minus 2, right? So y here can be either positive or y can be negative. So again, I get a yes, I get a no, insufficient. I'm going to knock off P. It's very easy to work with the two statements individually, right? But when I'm going to combine, right, this is where the strategy comes into play. As soon as you combine the statements, right, your mind should go towards either substituting one statement into the other or choosing a mathematical operation to use between the two. Here, right, I wouldn't choose a mathematical operation because one is an equality and the other is an inequality. So the better thing to do would be for me to substitute one into the other. So I have 2x minus 2y is equal to 1. So x minus y is half. And I also have x by y is greater than 1. And the question is asking me information about y. So what I'm going to do is I'm going to substitute x in terms of y. So I have x is equal to half plus y. I'm going to substitute that into my second statement. So half plus y divided by y is greater than 1. I'm going to split this fraction. So 1 by 2y plus y by y will give me 1 is greater than 1. And this finally gives me 1 by 2y is greater than 0. This is what I have when I mathematically or algebraically solve these two statements together, right? So I have 1 by 2y is greater than 0. Now think about it, right? For 1 by 2y to be greater than 0, the only way this is going to be possible if y is positive. That's the only way 1 by 2y will be greater than 0. So combined, the statements would again suffice. So the point I'm making, right, is whenever you see questions like this and you're combining statements, your first instinct should be, can I use a mathematical manipulation between these two to get to my answer? And you see how I mathematically manipulated not in terms of x but in terms of y because I wanted to answer what the question asks of me. Okay, all of you all, any doubts on this? Guys, okay with this? Can we continue to one more? And then, great. Okay. Any doubts on this on the previous question? Because if you can ask that of me now, I can quickly resolve that and go on to the next question. Right. So I want you to hold on to this. I'm starting off small. There's a lot more things that we have coming our way. Perfect. Okay. So here's your third question. Is x an integer? A good one. So be a little careful while answering. X square is an integer and x by 2 is not an integer. So same process. I'm going to give all of you all 2 minutes to solve. Your time starts now. Final 30 seconds, guys. Quickly type in your answers in the chat window. I see only two answers here. It's a good one. A lot of takeaways from this question. Okay, so I see that the answers are equally split between alpha and echo, right? Alpha would be like the most obvious trap, right? You should be very, 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 very careful. Remember, guys, what I told you, right? And it's important that you have that guideline of what I said. The key to how to proceed solving, right, always lies in this question stem. What the question stem gives you in terms of information, also what the question stem does not give you. If you look at this entire question, right, there are again no constraints that apply to X. And once you see a question that there are no constraints in, right, your initial instinct should be, okay, I need to plug in values here. And when you're plugging in values, right, your mind should go towards thinking of different types of values, not to try to prove the statement to be sufficient. I wanted to prove the statement to be insufficient. For most of y'all who said x square is an integer, and you all went with the analysis, if x square has to be an integer, x has to be an integer, that is not right. If x is an integer, then obviously x square has to be an integer. The reverse need not be true. So when I look at the first statement, right, x square is an integer, I don't see any constraints that apply in this question. So quickly I'm going to put in a value. So I know if I put x is equal to 1, 1 square is definitely an integer, and 1 is an integer, so it answers the question with a yes. But my approach is I'm going to try to contradict the initial answer that I've got. I need to think of a value which satisfies the statement but answers a no to the main question. I'm going to get a yes when x is an integer. I'm going to get a no when x is a fraction or a decimal or a root. And whenever you see squared terms, right, you can always use surds or roots to work with. If I put x is equal to root 2, root 2 whole square is definitely going to be an integer, but root 2 on its own is not an integer. So the first statement is not sufficient, PCE, right? So the point I'm making here and the big takeaway is, if you're forced to plug in, right, when you're working with the statements individually, always test for values in this order. Test for 0, test for 1. Don't forget to test for negative values. Also make sure you check for fractions and roots, both positive and negative. Okay, you see what I did? I put x is equal to 1, got a placeholder yes, but I tried to contradict this. I'm going to ask myself a question. What else can I substitute for x, which is not an integer, which satisfies x square as an integer, but doesn't give me x to be an integer? And the only value I could have thought of is a root, right? Root 2, root 3, whatever you want. So out goes AD. The second statement is more easier to work with, isn't it? Because it tells me x by 2 is not an integer. So if x by 2 is not an integer, x can be 1 because 1 by 2 is not an integer. It gives me a yes to the main question. And I can also put x is equal to root 2 again, right? Because root 2 by 2 is not an integer. So it gives me a no to the main question. Or I can put x is equal to 3 as well if I want, right? This will also give me a no. So out goes B. Now, why did I choose this question, right? Now, why did I choose this question at this point of time is to tell you that not always, right? Not always can you utilize a mathematical operation between one statement and the next, right? Most of the cases you will be able to, but at some points, right, when you're not able to mathematically manipulate the first and the second statement, you will have to proceed with values itself when you combine the two statements. So when I'm combining the two statements, I have x square to be an integer. See, why can't I use a mathematical operation between the two? Because one is telling me x square is an integer, the other one is telling me x by 2 is not an integer, right? How do I make that into an equation and work with it? I don't want to introduce more variables like x square is k and x by 2 is not equal to n and work with it, right? I'm just going to pick values which are going to satisfy both statements together, right? So clearly x is equal to 1 is a value that satisfies both statement together, or x is equal to 3, whatever you want. So 1 square is an integer, 1 by 2 is not an integer. So this gives me a yes to the main question, right? Because x is an integer. Now again, I'll have to think of a value which satisfies both statements but gives me a no to the main question. I cannot use a fraction because x square is an integer, means x can't be a fraction. I cannot use, say x is equal to 2 because 2 square is an integer, but 2 by 2 is not an integer. 2 by 2 is an integer, right? So it's not going to satisfy the second statement. So the only possible route that I can go to is think of using roots. So x is equal to root 2 is going to satisfy the first statement, it's going to satisfy the second statement, but it's going to give me a no to the main question. Echo. So the point I'm making with this question is this. Whenever you see any data sufficiency question, your initial instinct should be, I have to look at the question stem the way it is drafted and check whether I'm going the route of plugging in or the route of analysis. When do you choose plugging in? When constraints are not given. If constraints are given, always analyze. When you're working with the statements individually, try to put in values that satisfy the statement but answer the question with a yes and a no. Try to prove insufficiency. When you combine the statements, it's always better to substitute one into the other, use a mathematical operation between the two. But if that is not possible, right, you're not able to mathematically manipulate the two, you will have to proceed with thinking of different values that satisfy both. And again, you'll have to make sure you pick values that satisfies both statements simultaneously, but answers the main question with a yes and a no. Try to prove insufficiency again. Okay with this? It's a hard one, right? Most of y'all have given me A, but some of you, or most of y'all have given me E actually. Some of y'all have given me A. So for the people who have given me A, clear about why the first statement is not sufficient. Don't assume that if x square has to be an integer, x also is an integer. Okay with this, all of y'all? Perfect. Now, what if you have, now your question will be, what if you have, any constraint given, right? If you have any constraint given, no, always choose the route of analysis. Don't even bother about, plugging in values, right? So for example, if they tell me if a and b are integers, right, is ab even? First statement, 2a plus 7b is even. Second, say 7a plus 6b is even. So just giving you a clue. See guys, if I give you constraints like this, right, without any doubt in your head, quickly start analyze things in terms of evens and odds. Ideally, this question should be solved in 30 seconds. So I'm only going to give you 30 seconds of time to work with it. The time starts now. Perfect. So I see a good number of answers D. I still see a C and I still see an A, right? Okay. Very easy one to work with. If I see constraints given to me, I'm still directly going to analyze. The question asks me, is A, B even? And I've been told that A and B are integers. Now think about it, right? For the product AB to be even, provided both A and B are integers for me, I just need to prove whether one of A and B is even. Because any integer into an even value will always give me an even value, right? So looking at the first statement, Since a is always an integer, 2a will always be even. And I want 2a plus 7b to be even, right? The only way I can get an even from an even number is if 7b is also even. And for 7b to be even, b has to be even. So what is the information that the first statement is giving me? B is an even number. And think about it, right? If b is even and a is an integer, the product ab will always be even. So the first statement suffices. The second statement gives me 6b. So 6b by default is always even provided b is an integer. For 6, if 6b is even and I need an even value here, 7a has to be even. And for 7a to be even, a has to be even. So again, I need the product AB. Since A is given to me as even, the product AB will always be even. So delta. So you see how easy things become if I provide constraints there for you, right? You can either choose plugging in or you can analyze. I would prefer analyzing because it's much more faster. But if constraints are not given, right, you need to be doubly careful because one big trap that the GMAT lays for you, right, is for you to forget that numbers can also be fractions, both positive and negative, and roots as well. Okay with this, guys? Okay with the first, you know, most important basic strategies of data sufficiency, right? This is the foundations of data sufficiencies. We look at now, topic wise data sufficiency strategies by going to algebra and word problems in geometry. Is this okay? I would, prefer that you ask me certain doubts on what we discussed till now, because if you have some doubts, let's clarify that before we go further. So any doubts, quickly type in those doubts in the chat window, please. Kanha, it's okay even if you take one out of A and B as negative, right? So even if you take a value of A and B as negative, no, 2A will still be even, right? Because I'll have to put values like A to be -2 or -4. So that's still not going to change the fact that 2A will be even, right? Think about it, no? If you put a negative value, put any negative value you want, -1, -2, -3. 2 into -1 is -2, -2 is even. 2 into -2 is -4, -4 is even. 2 into -3 is -6, right? An even number is defined as something which is always divisible by 2, right? And even numbers can be both positive or negative, okay? Don't assume that even numbers are only positive integers. Okay with this, guys? All of y'all? I wanted to have a hang of what I just told you, because when you go to the next question, things become a little more complicated. Okay, you'll have to utilize what we discussed before on those questions. Okay with this, guys? All of y'all? No problems? Suppose this question is a yes or no question. Now, if statement one, okay, so this is the question that Khanam has put forward. Suppose this question is a yes or no question. Now, if statement one directly says it is a yes, then we should try to find a yes in statement two. No, Khanam, I think you're mistaken about what the process of a data sufficiency is. A data sufficiency is a question given to you, and there are two statements. You'll have to look at them both individually. The two statements are like additional pieces of data that you'll have to utilize to check whether that data is sufficient to solve or not. Okay, so when you work with the first statement separately and the second statement separately, you don't need to get influence from the first when you go to the second. Okay, so if the first statement gives you a yes, the second statement can give you a yes or a no. You have to look at them individually, don't combine them at this point. Even numbers are not only positive, okay, Kanha, it's both positive as well as negative, right? So even number definition is anything which is divisible by 2. So -2 is divisible by 2, isn't it? Yeah, I'm coming to that. Can you give me more examples for traps? I already gave you like the good 3, 4 examples, right? The basic example of traps on a data sufficiency, right? Okay, since somebody has asked that, I will put this across. The first trap of a data sufficiency is to carry information from the first statement to the second, from statement 1 to statement 2. Second trap of data sufficiencies is to assume all values are integers. The third trap of a data sufficiency is for people who try to prove sufficiency. People will always try to prove sufficiency. They'll not try to prove insufficiency. The fourth trap of data sufficiency we'll look at once we go to geometry and algebra. Okay. So at this point, these would be the three traps. Always keep in mind, think of analysis only when constraints are given. Always plug in values if constraints are not given. It's safer that way. Okay. Now, what are the other traps if you ask me, right? For example, in algebra, no? This is what they would do. So say x and y are positive integers. What is the value of x? Okay. First statement, 29x plus 15y is equal to 440. And second statement, say this is not an official question, but I'm just giving you an example. Okay. So 2x plus 3y is equal to 12. Now, since somebody asked me about the traps, right? By looking at this question, no, what most test takers will do is they'll start assuming that if I have an equation, one equation with two variables, I will not be able to solve that equation. So I'm just going to use that statement to be insufficient and move on to the next. And people will just skip the two statements individually rather than checking for them step by step by step. I'm not going to work this question entirely, but I'm just going to think about it like this. See, when I give you constraints like this, right? X and y are positive integers, and I give you a algebraic equation 29x plus 15y is equal to 440. You just can't discard the statement and say that I'll not be able to solve for x and y and get a unique answer. You'll have to plug in values and you'll have to check. Why? Because I've given you this constraint that x and y are positive integers. So when you see something like this and you feel that, okay, I feel this is insufficient, if you have that mindset in your head, I feel this is insufficient because of two variables, it's always better to take a step back and prove insufficiency. I told you, right? Don't prove things to be sufficient, always try to prove things to be insufficient. This is an example for it. So if I get 29x plus 15y is 440, right? Immediately I'll not keep the equation like this. When I see the coefficient of y is 15, I will try to make it 0 because it becomes easier for me to work with. So I'm going to double this equation. 58x plus 30y is equal to 880. You see what I'm doing is I'm not changing the equation, I'm manipulating it. And the reason I'm doing that, right, is I know that I'll have to think of putting in values for x and y which satisfy this equation. So 30y, since y is an integer, will always end with 0. And 880, right, is a value which by default ends with 0. So the only way I can get an overall units digit of 0, if 30y gives me a 0, is that 58x also has to give me something ending with 0. So you see, I'm not letting go of that statement. So the first thing I will do is I'll plug in a value x is equal to 5. I'm going to do it this side. So x is equal to 5. So if I plug in x is equal to 5, 58 into 5 plus 30 into y is 880. So 30y, 58 into 5 is 290. So it's 880 minus 290 is 590. That gives me y to be 59 by 3. But this doesn't make sense, right? Because I've told you x and y are positive integers. So I know x is equal to 5 is definitely not a solution. So the next value that I'm going to plug in for x is a value which ends with 0, right? Which gives me 58x to end with 0. So x is equal to 10. And here you'll realize 58 into 10 plus 30 into y is 880 basically means 30y is 300. So y will also be equal to 10. So you see x is 10 and y is equal to 10 is definitely a possibility to satisfy this equation. So what do I need now? I need confirmation that that is the only possibility to work with. So the next value I'm going to plug in for x is equal to 15. Because 58 into 15 also gives me something ending with 0. But 58 into 15, 15 8s are 120. 15 5s are 75 plus 12 is 870, right? Plus 30y is 880. You see what happens? 30y is 10. So y is 1 by 3. doesn't definitely satisfy the constraints. And I'll realize that if I put any other value beyond 15 now, the value of y will start becoming negative. So I know there's only one possible solution for this entire equation given the constraints that x and y are positive integers, x is equal to 10 and y is equal to 10. So that is why I made the point, right, that when you work with data sufficiency statements, don't try to prove sufficiency. Always try to prove insufficiency, right? And when constraints are given, no, you never discard the statement, right? You always say, okay, how do I prove this to be insufficient? If you're not able to prove it to be insufficient, then you hold on to it. Make sense? So somebody asked me for, what the couple of traps are. I'm just giving you one here so that you understand how it works. Okay, all of you all. Khanam, this is not a yes no data sufficiency, right? This is a value data sufficiency. There are two kinds of data sufficiency, right? It's a yes no and a value. For a yes no, you answer the question with a yes or a no. For a value data sufficiency, you get to a definite answer, right? It's like me asking you, right? For people who are new to data sufficiency, this is something that you'll have to get fixed in the first stage itself. For a value data sufficiency, right? The questions will be framed in this form. What is the value of x? It's like asking you what is my name, right? If I ask you what is my name, then the only way you can answer this if you get one unique answer. You have to test for uniqueness and you have to get a definite value for the answer. In a yes or no data sufficiency, it will be in this form: is x equal to 5, right? So it's like, is my name Aditya, right? Something like this. So if I ask you the question, is my name Aditya, there are two ways you can answer this question, or three ways. Let me put it that way. Three ways to answer this question. You can say, yes, your name is Aditya. You can say, no, your name is not Aditya. Or you can say, maybe your name is Aditya. If you get a definite yes, it is sufficient. You get a definite no, it is also sufficient. But if you get a maybe scenario, that is where things become insufficient. Got it? So for those who are beginning data sufficiency, that is the basic rule of breaking things down. Okay. Okay with this, guys. Khanam, is x positive? If you ask me that question, right, is x positive question mark, and the first statement is 29x plus 15y is equal to 440. Then if I give you x and y are positive integers, then the answer to that will definitely be a yes, because the only possible value you'll get is x is 10, y is equal to 10. So the first statement is sufficient. The second statement is 2x plus 3y is equal to 12, right? So check if that statement is enough or not. But see, the second statement is 2x plus 3y is equal to 12, right? And I've put in constraints that x and y are positive integers. Now, why I didn't worry about solving this is because I assume most of you all will know how to work with it. Think about this, guys. Okay, if I give you the constraint that x and y are positive integers, and I give you an equation 2x plus 3y is equal to 12, what is the only possible solution that you can get? You can do it in your head. You don't even need to worry. Right? What do you think the solution is going to be if I give you this equation 2x plus 3y is equal to 12 and mention that x and y are positive integers? Would you get only one solution or would you get multiple possibilities? Perfect. The only possibilities you'll get is x is equal to 3 and y is equal to 2, because 2 into 3 will give me a 6. 3 into 2 will give me a 6. I can't think of any other value. This was a much easier equation to solve than 29x plus 15y, right? So I won't even bother too much about it. So x is 3 and y is equal to 2 is the only possible solution to it. So it's satisfying that statement, isn't it? Okay. Yeah, if the statement one, Khanam, if the statement one says yes, means it's answering the question with a definite yes, right? That's when you say the statement one is sufficient, right? So if you got a definite yes, you try to contradict. If you're not able to contradict, you cannot, that statement would be sufficient, because the only way I've got a solution to the first statement is x is 10, and that's answering the question. Your question that you gave me is x positive, right? With a definite yes. So I'm holding on to it. UNC, you need to understand that I'm working with data sufficiency on the whole, right? So I'm not picking, I'm not picking topics which are very concept heavy. because here you see that couple of people, need a starting of data sufficiency, right? So I'm not going to pick questions on mean and average at this point of time, okay, and range. I can do it, but I'm going to stick to the ppts that I have, okay. All right. So the second strategy is, what do you do when you have complex mathematical equations in terms of inequalities, absolute values, or you have word problems. Okay, this is an example of a word problem, right? So what I want all of you all to do, again, same procedure. I want you to take 2 minutes, try this out. This is an example of an average itself, so no problems there. Your time starts now. It's a very simple one, right? It's just that the question is longer than the solution to it, right? That's how it is. So it's a huge takeaway that I have here, and that's especially, I know people struggle with inequalities and absolute values, and with word problems. So think about it. Final 30 seconds. Okay, so let's look at the answers. So good split again between answer choice B and answer choice C, right? Almost half of you all have given me C. Good amount of you all given me B as well. Now, to be very truthful, right? This question is like a 1 minute of calculation, not too much of time to spend on this. But the first trap, somebody asked me what are the different traps on a data sufficiency, right? So if anybody is drafting a question on data sufficiency, right, this is a most prevalent trap that you'll find, and this is called the classic C trap. Okay, for those who answered C, you basically fell for this trap, because obviously for you, no, it'll be that looking at the two statements combined will be sufficient. Now, like I told you, right, if you try to prove sufficiency, you will fall for this trap. But if you respected the data sufficiency structure, right, and you work with the two statements individually, you would get to the answer very, very quickly. The big takeaway is when you're working with complex mathematical equations or you're working with word problems like this, the best way to approach any data sufficiency question is to spend time on the question stem. Work on the question stem. Many people jump into the statements very, very quickly, right? I'm telling you that the question stem is key to solving the question. And how do you work on the question stem? You rephrase the question stem and you try to rephrase what the question is actually asking you to find. What happens, right, when the GMAT creates a data sufficiency question, they would always give you complex pieces of information which can be broken down into much simpler forms. So when you see a complex mathematical equation on algebra, right, or a word problem, your eye should always go to the question stem and try to break it down and rephrase the data sufficiency. If you're able to do that, right, it will save you time to work with the statements that will make you, it'll avoid you falling for these traps. So let's break this down. In a certain year, the difference between Mary's and Jim's annual salaries was twice the difference between Mary's and Kate's annual salaries. If Mary's annual salary was the highest of the three people. So what I have in this first three lines is an equation. I have M minus J is equal to 2 times M minus K. You see why I did M minus J and not J minus M? Because clearly they have mentioned Mary's annual salary was the highest of the three people. And the question asked me what was the average annual salary of the three people that year. See, when you're working with the question stem, right, it always makes sense to actually write down what the question is asking you to find. Not in the terms of average is equal to what. Okay, many of you all would just write this. No, to find the average, what mathematical operation are you doing? So what the question is asking me to find is what is the value of m plus j plus k divided by 3. If you write this down, right, you're basically working with the question stem. You know what the question is asking you. You can actually rephrase the data sufficiency better. So you see what I have? I have two equations. I have one equation here, and this is the equation I have to solve for. So instead of jumping into the statements, right, I can actually leverage that to my advantage. So m minus j is equal to 2m minus 2k. I'm going to take the m to the left hand right hand side. So 2k minus j is equal to m. So I have m plus j is equal to 2k. So what the question stem is giving me is information that m plus j is equal to 2k. And what the question is asking me to find out is what is the value of m plus j plus k. I already know m plus j is 2k. So I can rephrase the data sufficiency by saying m plus j is 2k. So 2k plus k divided by 3 is what? 2k plus k is 3k. So 3k by 3 is what? I can knock off the 3 on both sides. So the question is asking me what is the value of k. So you see what I've done? I've simplified that complex mathematical equations into a much simpler data sufficiency question. And the question is just asking what is Kate's annual salary? The first statement gives me Jim's annual salary. That clearly is insufficient. BCE. The second statement spoon feeds me with what I exactly need, right? So the second statement would always hold beta. So the point I'm making, the second strategy I'm giving you here is this. When you work with complex mathematical equations, right, like inequalities, absolute values, or word problems like averages, like mean, median, modes, like say ratios, proportions, percentages, speed, distance, time on a data sufficiency, the best thing to do is to always set up the equation based on the question stem and try to rephrase the data sufficiency and see what hidden piece of information it's actually asking you to find out. Because if you leverage the question stem and spend time on the question stem, right, the statements become way easier for you to solve. Make sense? All of you all? Any questions on this? And I gave you one more, C trap basically here. This is another trap that the GMAT would normally test you on. Okay with this, guys? For those who answered C and those who answered E, there's always merit in breaking down the question stem. Okay with this, all of y'all? Because now we're going to work on this, understanding of this strategy. So can we continue? Great. Okay. So here's the next question. Guys, again, I want you to implement what we just discussed in the previous question here. So remember, you don't need to plug in values and work with things, right? If you spend time on the question stem and rephrase it and figure out what the question actually asks. So again, I'm going to give you 2 minutes. You 2 minutes start now. Final 30 seconds, guys. Okay, final call for answers. Quickly type in what you feel is the right answer. Okay, don't worry about what you pick. We'll discuss this, and then if you got it right, good. If you're not, let's see where you've gone wrong. Okay, so I see most of you all have answered A. Some of you all have given me D. There are a couple of C's as well. A very easy one to work with. Like I said, right, there's always merit in breaking down the question stem. So let's work with it. Henry purchased 3 items during a sale. He received a 20% discount of the regular price of the most expensive item. So let me keep the most expensive item to be X, and a 10% discount of the regular price of the other 2 items. So let me keep the other 2 items to be Y and Z. He receives a 20% discount, right? So the discount received here is 20 by 100X. The discount here is 10 by 100Y. And the discount here is 10 by 100Z. And the question says, was the total discount greater than 15% of the sum of the regular prices of the three items. So this total, is this greater than 15% of the sum of the regular prices of the three items? That is what I want. See, this is my equation that I've broken down by looking at the question stem. But you see, I'm not going to set this up and jump into the statements very quickly. Where I see a possibility to simplify, I will take that possibility. So I can knock off the 100 throughout, multiply the entire equation by 100. So I have 20x plus 10y plus 10z is greater than 15x plus 15y plus 15z. I'll take the x to the left and the y and z to the right. So 5x is greater than 5y plus 5z. So x is greater than y plus z. You see, that's what the question is actually asking me. Right? It's asking me, is x greater than y plus z? Or basically, is the price, the regular price of the most expensive item greater than the sum of the regular prices of the other two items? If I figure that out, my statements become very simple to work with, because the first statement says x is 50 and y is 20. And you see how they worded it, right? The regular price of the most expensive item was 50, that's x. And the regular price of the next most expensive item, so let's call the next most expensive item as y, right? That's given to me as 20. Now think about it, right? If the most expensive item is 50 and the next most expensive item is 20, then z, which is the least expensive item, has to be less than 20. So the first statement is giving me x is 50, y is 20, and z to be less than 20. And this statement is clearly going to be sufficient for me to answer the question, right? Because if x is 50 and y is 20 and z is less than 20, y plus z will always be less than 40. And x is always 50, right? So 50 is always going to be greater than any value less than 40. So it answers the question with a definite yes, sufficient. The second statement, though, is very easy for me to eliminate, right? Because it just tells me z is equal to 15. It doesn't tell me what values x and y can take. Don't carry the information from the first to the second. If z is equal to 15, I don't know what x is, I don't know what y is. X can be 17, y can be 16, or x can be 300, y can be 17, right? So I can get a yes, I can get a no, insufficient, alpha. Got it? So you see, I didn't have to work with the statements individually, right? By putting in values. All I had to focus on was try to break down the question stem, right? So on word problems, the key is the question stem. The setup of the entire question makes you working simpler for statements. And even when you work with complex mathematical equations like inequalities and absolute values, we'll look at an example after this. The same thing holds. Any doubts here, guys? It's not Ritik, it's not a very hard question, right? I would classify this as a mid 600 one itself. Okay, the next one that I'm giving you is definitely a 700 level question that we work. Okay, okay with this, guys, all of y'all? No problems? Okay with the concept of how to use the question stem to your advantage and break it down and rephrase the data sufficiency, because that will be clearly important once we look at an inequality or an absolute value one, right? So here's your next question. It's a tough one, a hard 700 level question. Your time starts now. Final 30 seconds, guys. It's a hard one. Okay, so let's have a look at the answers. Lot of A's, some B's, some D's, some E's, some expletives as well. Okay. Found it hard? How many of you all found this question, very, very hard, right? Quickly add a +1 if you found this very, very hard. There are two things. There's a reason why I brought this question in. One is to, justify my point that it makes sense for you to break down the question stem. The other one is to also give you an insight into how difficult, or basically a strategy into how to solve absolute value questions, right? I see a couple of y'all have given me a D, which is absolutely fine. Others have given me A's. The others have not bothered answering things at all. Okay. Great, great. Okay, so let's have a look at this question. Let's have a discussion on it. Okay. Obviously, right? Obviously, I'm not going to jump into the statements. I'm going to leverage the question stem. And what the question stem tells me is absolute value of x plus 2 is equal to the absolute value of y plus 2. Now, if you ask me, right, what is the most easiest topic on the entire GMAT, I would point out to this topic of absolute values, right, because they are very quick to solve, provided you understand what the concept of an absolute value is. So here is one strategy to solve absolute value questions quickly, especially when you have a question where you have an absolute value on both sides. Now, whenever you have an absolute value on both sides of an equality, right, or an inequality, the best thing to do is to square both sides and remove the absolute value. Why? Because we have one definite relationship, or one big relationship. Mod of x, or absolute value of x, is always equal to the root of x square. So whenever you see a mod of x plus 2, it is actually root of x plus 2 whole square. So to remove the roots, you can always square both sides. So whenever you see an absolute value on both sides, right, of an equality or an inequality, you can always square both sides and simplify the entire equation. So x plus 2 whole square is equal to y plus 2 whole square, right? Now I'm not going to open the brackets and simplify, right? I'm just going to take things to the left hand side. X plus 2 whole square minus y plus 2 whole square is equal to 0. And this is in the form of a square minus b square. So a plus b into a minus b is equal to 0. So I have x plus y plus 4. And here I can cancel out the 2 and minus 2 into x minus y is equal to 0. You see, I get the factored form directly. So what this question stem, right, is actually giving me is it's giving me two possible values for x and y. So it's telling me either x plus y plus 4 is equal to 0 or x minus y is equal to 0. So it's giving me two possible solutions. Either x plus y is equal to minus 4 or x is equal to y. This is what the question stem is giving me. So the question now is basically, if x plus y is minus 4 or x is equal to y, what is the value of x plus y? That's what the question is, right? What they're telling me, they're giving me only two possibilities. X plus y is minus 4 or x is equal to y. And they're asking me, using those two possibilities only, what is the value of x plus y? You'll realize I've already got a value for x plus y as minus 4. But I've also got x is equal to y. So somehow or the other, right, if I'm able to prove that x is not equal to y, then I can knock off this possibility, and what I'm left out with is x plus y is equal to minus 4. The first statement gives me xy is less than 0. You see what it's given? They're telling me x into y is less than 0. So if I analyze the statement, right, it basically tells me x and y have to have both different signs. Now think about it, right? If x and y are going to have different signs, I know I definitely cannot say x is equal to y. So that is a complete possibility that I'm going to rule out. So what I'm left out with is only one remaining possibility, that x plus y is equal to minus 4. And that is sufficient for me to answer the question. AD. The second statement tells me x is greater than 2 and y is less than 2. Now think about it, right? Picturize x greater than 2. That's 2 onwards to the right. And y less than 2. That's 2 onwards to the left. If x is greater than 2 and y is greater than 2, again I can say that x cannot be equal to y. It's not possible for me to have x to be equal to y. So I know I can knock off this possibility. So I'm left with only one possibility now, that x plus y is equal to minus 4. And that is enough again to answer the question with a definite value. So the answer here is delta. Okay with this, guys? All of y'all? Yes, it's a very, very, very tricky one. It's a good question, right? The takeaway here is, first takeaway in terms of data sufficiency, what we are dealing with today, always remember to spend time on the question stem. When you have complex mathematical equations, you have word problems. The second big takeaway is a strategy of absolute values. When you have an absolute value on both sides, right, of an equality or an inequality, the best thing to do is to square both sides and remove the absolute value. Why? Because you have a relationship that the absolute value of x is always equal to root of x squared. Make sense? All of y'all? Any doubts on this? So if you have got this, we're going to consolidate everything in the final question for the day, right? And then again, that final question would be a good 700 level one. Guys, any specific doubts that you would want to ask of me in the previous question, or is the explanation clear? Can we move on then to the next question? No problems? Okay. Yes. Okay. So here's the last question for the day, right? And this question, keep in mind, we consolidate everything that we've learned from the first and the second and the third questions, and including the ones on word problems. Okay, so make sure that you set up the question right. Make sure you work with the statements right. Don't discard anything without actually proving things to be insufficient. Your time starts now. Last 30 seconds. Okay, so let's look at your answers first. So most of you all give me E, some with C, some with B. Vishal says A. The others, I'm assuming, have already given up on this question. It's a hard one, but again, a good takeaway, right? Umang, any specific values for absolute value questions other than squaring? Umang, there are a lot of say special things that you can do with absolute values, right? It's a lot of strategies, but I don't think it makes sense, for a data sufficiency webinar to bring in all of those. Uh, it's maybe later, right? Once we have another webinar, I may take this as a topic of absolute values, right? Great. So let's have a look at this question, okay? Because it's a very good one, and this is what the how GMAC would actually set up questions to push you towards falling for a trap, right? Um, so the question says Raiko drove from point A to point B at a constant speed, and then returned to A along the same route at a different constant speed. So you see, what they're telling me is the distance is constant. He travels at some speed from A to B. So let me call that S of AB, and he travels back at a different constant speed. So let me call that the S of BA. So the question says that Raiko traveled from A to B at a speed greater than 40 miles per hour. So the question is SAB greater than 40? Now clearly here, I've set up the question. I don't need to simplify the question stem because it's very straightforward. It's just asking me whether the speed from A to B is greater than 40. But what I have to be aware of, it's a yes no data sufficiency. So when I work with the statements, I need to try to prove insufficiency, right? I need to try to get a scenario where I get a yes and I get a no to the main question. So there's nothing for me to break down here. So I'm directly going to the first statement. The first statement says Raiko's average speed for the entire round trip, excluding the time spent at point B, was 80 miles per hour. Now, if you have distance as constant, right? Now, this is a conceptual, question. If distance is constant, the average speed is always given by 2AB by A plus B, where A and B are the upward journey speeds and downward journey speeds, respectively. So, what the statement is basically giving me is the average speed is 80, which is equal to 2 speed of A to B into the speed of B to A divided by the speed of A to B plus the speed of B to A. Right? This is what the statement is actually giving me. Now, what most of y'all did who answered E and C and any other answer other than alpha, right? What most of y'all did is y'all went with gut feel. Y'all said that looking at this statement, I have one equation with two variables. I'm not going to be able to solve. I'll get multiple possibilities. So SAB can be greater than 40, SAB can be less than 40, insufficient. If you find yourself doing that, right, by saying that, okay, I'm discarding a statement without actually proving it to be insufficient, you're falling for really well laid traps. Okay. When you work with a statement, when you get to an equation, right, don't just assume that an equation is just not going to be sufficient because it has two variables. You try to put in some values or you try to mathematically manipulate it such that it answers the question with a yes or no. Don't let a statement go like that otherwise, okay? So I'm going to simplify this. You see what I'm going to do? This is 40. So I basically have 40 is equal to SAB into SBA divided by SAB plus SBA. I'm not going to let this go. Now, plugging in values, right, is going to be slightly hard for me because I don't know what values to choose for SAB and SBA to give me 40. That's very difficult for me to work with. So what I would always do is I would work for what the question asks me. What is the question asking me? Information about SAB. So I'll try to make that the subject. So I'm going to multiply this here. That's 40 SAB plus SBA. And I'll take the SBA down here, divided by SBA is equal to SAB. Now I want you all to analyze this entire fraction, right? SAB plus SBA is going to be some value which is definitely going to be bigger than SBA. Agree? So if you take SAB plus SBA and you divide it by SBA, this entire fraction is going to give you a value which is greater than 1. Or if you want me to prove it further, I'll do one extra step, 40. I'll split this fraction. So I have SAB divided by SBA plus SBA divided by SBA is 1 is equal to SAB. So you see what's happening? SAB is equal to 40 into 1 plus some fraction. And when you have 1 plus some fraction, right, that value is always going to be greater than 1. And if I multiply it by 40, the value is always going to be greater than 40. So you see what's happening? It's answering the question with a definite yes. So the first statement is sufficient. So you see what I did is I didn't prove insufficiency by saying that I feel it is insufficient because it has one equation with two variables. You always have to prove insufficiency. Keep that in mind. So what did I do? Since it's very hard for me to plug in values, I try to manipulate the statement to match with what the question asks, because the question asking me about SAB. And then I try to analyze out of it, is there something that I can take away? So clearly the first statement was not sufficient. Now let's take the second statement. The second statement says, it took Raiko 20 more minutes to drive from A to B than to make the return trip. So the time of A to B is going to be the time from B to A plus 20 minutes, right? So 20 minutes is 20 by 60, which is 1 by 3. So what they're telling me is they're telling me the time from A to B is equal to the time from B to A plus 1 by 3. But the question is asking for the speed of AB, right? Since I know the distance is constant, if the distance is constant, the speed of AB into the time of AB is equal to the speed of BA into the time of BA, right? Speed is equal to distance by time, right? So distance is speed into time. If the distance is constant in both cases, the speed into time should be the same in both cases, right? So again, I have SAB is equal to SBA into TBA divided by TAB. And you see what happens here now. I'm free to take any value I want for SBA, and I'm free to take any value I want for TAB and TBA, because I know this relationship that TAB is TBA plus 1 by 3. So I can take any value I want for TBA, I can take any value I want for SBA. So if I can take any values for those two, I know that the value of SAB can be greater than 40 or it can be less than 40. For example, if I take SBA to be 40 itself, and I say TBA is equal to 1, right? So 40 into 1 divided by 1 plus 1 by 3 is 4 by 3, right? So clearly you're going to get a value which is less than 40. But I can also take SBA as 1000, absolutely fine. And I can TBA as 1, right? So it's possible for me to get a value of SAB to be greater than 40. You see what I'm doing is I'm not discarding just by looking at the fact that there's so many variables. I'm quickly putting values in my head and know, and I can easily identify that I can choose any values I want for SBA and TBA. But here, I couldn't choose any random values I want for SAB and SBA because I had to work for the 40. So what did I do? Instead of plugging in values, I quickly simplified. So the second is insufficient, alpha. Make sense, guys? Another tricky one, right? Keep in mind, if you break down the question stem, you respect the structure of any data sufficiency. Don't discard statements because you feel it is insufficient. Things become very simple to work with. Okay, great. So quick, that's the last question for the day. So a quick 5-minute Q&A, right? So if you have any questions that you would want to ask me, we can quickly have a discussion. If not, then we can wrap up with this session, and then maybe I can see you sometime later with maybe some other topic. Perfect. So I can repost the 3 ground rules. Let me write it down then. Right, I'm just going to put DS here. First, when you work with the data sufficiency question, ask yourself a question whether you're going to analyze or plug in. Right? When do you choose to analyze? When you're always going to get constraints. Constraints are given. When are you going to plug in values? When constraints are not given. Second, when you're working with data sufficiency statements, right, your approach is to always try to prove insufficiency. Try to prove insufficiency. Right? Always try to prove insufficiency. Never try to prove a statement to be sufficient. If it's a value data sufficiency, try to see if you are able to get 2 possibilities so that you can discard the statement. If it's a yes no data sufficiency, try to see if you can get a yes and a no. See, a negative mentality is very important, because then, if you ask yourself a question in your head, what do I put here to negate my first answer, it's easier for you to work with. Otherwise you'll fall for a lot of traps. The third is, when you're combining statements, always use one statement into the other, or substitute basically, right? Or use a mathematical operation or a combination of mathematical operations between the 2 statements. Very important when you combine statements. If you're not able to use a mathematical operation, no problem. Directly go with analysis or plugging in. Fourth, when you're dealing with complex mathematical equations or you're dealing with word problems, the key always lies in the question stem. Spend time on the question stem, break down the question stem, and always rephrase the data sufficiency. Okay, if you keep these things in mind, this becomes a very, very easy topic to work with. Okay, so that's like a summary of everything that we discussed. And in the process of giving you the summary, I also spoke about not discarding a statement with 2 variables just because it has one equation with 2 variables. I also spoke about a strategy of how to work with absolute values. When you have absolute values on both sides of an equality, it's always better to square both sides and remove the absolute value. Right? Perfect. So that was a summary. Ashwin, if time permits and if you are able to schedule that session on absolute values, I don't mind doing that. Okay, so let's look at it sometime later if it's possible. How to know when to end while substituting values? How can we be sure that there won't be another scenario? Yes, that's a good question, Appy. So that's why I'm asking you, right? When you're working with data sufficiency questions, you're plugging in, right? The thought process should always be in terms of what number should I do to contradict the initial answer. That is the downside towards plugging. The downside towards plugging in, you'll not know where to stop. Okay, so if ideally you shouldn't go into a question plugging in values if you don't know where to stop, right? I would go the route of analysis at that point. Perfect. Shubham J, the squaring trick is not for a data sufficiency, Shubham. The squaring trick is for a absolute value question. Okay, so you can take it as an absolute value strategy. I'm not going to add it in the data sufficiency bits, but the rule is, when you have an absolute value on both sides, you always square both sides and remove the absolute value. Okay, guys, I think that's all we have. Any last questions I can take for around 3 minutes? Any last questions, and then we can wrap up. Yes, Joydeep, the answer is A. for the previous one. Okay, guys, great. Perfect. So I hope to see you then if you're going to take up a next session. Thank you so much. Have a good night. Good night. Take care.